So we're going to take a look at what bootstrapping is and answer some questions with regards to this. Remember that you're going to have to write a little bit of a paragraph about the method of bootstrapping and why we bootstrap. So first of all, the best method that we have for getting information about the population is to take a sample from that population, and that's the best way of getting information about means and medians back in the population. Now, when we bootstrap, we're not taking a sample from the population over and over and over again. That's one thing that we could do. But with bootstrapping, what we do is the sample that we have pulled out from the population, what we do with that sample that we have is we do resampling, repeated resampling from that single sample that we have. And we do it with replacement. So resampling from the sample gives us the same information, it's been proven, as repeated sampling from the population. So resampling, bootstrapping is a good method, and it can be done very quickly by software. So this is the strategy that we use. We use bootstrapping or resampling with replacement from a given sample. The reason that we're going to create a confidence interval through doing this, we know, is because when we take a sample, we know that every sample that we take is going to be different from each other. We know this from sampling error and sample variability, and that is also going to be the case if we resample from our sample. So instead of collecting a bunch of single samples from the population, what we do is we take our sample that we've created, the original sample, and then we just pull out individuals, same size a sample, resample from that, and then keep putting the individuals back in, called replacement, and then pulling out another sample. So what happens is we create resampling or bootstrap samples from the single sample, and they are all going to be different because the fact of the matter is we're doing it replacement, so that makes each sample unique. Now I'm just going to show you an example of how this all works with a very basic example. Let's say we want to take an apple orchard and we want to find out in the population of the orchard what the median weight of the apples is in that particular orchard. So we're going to take a sample of 15 apples and measure their weights. And then what's going to happen is we're going to do bootstrapping. And we don't bootstrap individually by hand. We get software like Enzyte to do the bootstrapping for us. So here's our sample of 15 apples. Enzyte has determined that the median weight for our sample is 149.27 grams. Now the fact of the matter is that sample could very well, or that median for our sample could very well be wrong. If we go back into the population and we try to determine what the population median is, this could very well be incorrect. We don't know. This is just one sample. We know if we took another sample, it could be quite different. So we're going to create a confidence interval, and that's why we use a confidence interval to determine what's going on back in the population instead of this point estimate. So we've got our sample, and now what we do is we get Enzyte to create a resample or a bootstrap sample. So from this sample of 15, we resample from that and create another sample. Now you'll notice that this resample is not exactly the same as this one. Some values are missing. Some values are used more often because the resample is unique and it's pulled out from this. Then we put the individuals back in, and so sometimes people or apples get chosen more often than actually happen in the original sample. Some get left off completely, so we've got a completely unique resample. And we see that the median for that resample is different from our original sample, which is what we would expect to be. Now we just keep doing this. So what we get Enzyte to do is to resample, to bootstrap sample 1,000 times from that original sample. And we get all these variations of medians. Each one of these blue bands represents a median from our resample. So we take 1,000 of those, and then we get Enzyte to create something called a bootstrap distribution. So all of these medians are dropped down and create a dot plot distribution. And each one of these represents a median. It says mean, but it's actually a median from up here. And we can see the distribution of that. And then what happens is Enzyte will enable us to create a Bootstrap confidence interval from this distribution. So we drop off the extreme highs and lows, 2.5%, 2.5%, and create a confidence interval, what's called a 95% confidence interval. It ranges from 147.07 to 151.4 in this particular example. So what happens is we get what's called a 95% confidence interval for the medians of the apples in this orchard. And what that enables us to do is say that we are reasonably certain that the median weight back in the population of apples in the orchard will lie somewhere between 147 and 151 grams. And so we can be reasonably certain that back in the population, the median weight will lie somewhere between these two values. Somewhere in here. We're not sure exactly where. Each sample tells us, a different story. But generally speaking, we know that the median of the population will fall somewhere in between here.